So we're going to go ahead and head into quasi-experimental designs for this particular unit. When it comes to quasi-experimental designs, there's a few things to keep in mind. First of all, a lot of these designs are going to be fairly similar to experiments that you've seen before. But what it does is recognize that you can't always have a control group or random assignment. Sometimes there are limitations in terms of the population. You can't have different groups of people. You can't randomly assign them. So this recognizes the reality of research, that there are times where these things aren't possible, and what sorts of designs we have and how we think about them in terms of their various strengths and weaknesses when we cannot have a pure experimental design. The tricky thing with quasi-experimental designs is that causation is impossible to truly establish. So you must be cautious with your language and not overstate results. This is the poorest design that you can have, which is a one-group post-test only design. We're using our notation system again, where X means some sort of intervention or manipulation, and O means some sort of observation. So for example, a measure of some kind. So let's say, for example, you were working with a group of people and you wanted to see if therapy improved outcomes. So after they had finished their therapy, you asked them a series of questions about how well they'd done on the therapy. This is also known as a one-shot case study. Sometimes you can use that to measure a unique event. So for example, there's a lot of people who are doing research right now on responses to the pandemic and stress levels around the pandemic. The pandemic can be thought of as X, and measures of how stressed people are can be thought of as O. People didn't think ahead of time to measure people's stress before the pandemic. It kind of happened, and then we're trying to measure it after the fact in order to figure out how people are coping with it. So in this particular case, people couldn't have anticipated in order to have a pretest, and there's really no way to have a control group or comparison because everyone's going through it in one way or another. Sometimes people use this in order to engage in program assessment, once again after the fact, after an event has already happened, to go in and try to see how people are responding, what they've learned, how they're coping, how they're feeling, how they're thinking, when you might not necessarily have a comparison group or have had the ability or foresight to measure a pretest. This tends to have all the weaknesses of a post-test only control group design with some additional issues. Because there's no comparison group, you can't determine if the change was due to the intervention or was due to something else. So you can see how making a causal argument is really shaky here. But this is still something that people sometimes have to do based on the nature of what it is that they're studying. So this would say a theoretical control group response could be implied, but because it's not tested, you don't necessarily have that. So if all you had was the group who had the intervention, you could say, well, here was their response and it was above the mean, but you don't necessarily have a control group in order to be able to compare it to see if it actually was different from the people who didn't have the intervention. Here's where there's a single group, but you've had the ability to engage in a pretest. So this is where you're measuring before and after for a single group of people. So you have an initial pretest and then some sort of intervention or manipulation, and then a post-test in order to take a look at change over time. This is slightly better than just a post-test only one group design, but the threats to internal validity are still very high. Because there's no comparison group, you can't determine whether change over time was due to X or was due to things like maturation or testing, regression to the mean. Having a comparison group helps you be able to determine if change is due to one of those threats to internal validity or due to your manipulation. So there's a lot of questions about whether change is due to X or due to an outside factor when you have this sort of design without a comparison group. This is, once again, slightly better than number one, which was just the worst possible type of design that you can do. But once again, sometimes we have our limits. In this particular case, there are two groups, but they're missing a key component. There's no little r there. They haven't been randomly assigned. So you have group A and group B, but you haven't randomly assigned them. So these might be pre-existing groups. So classroom A, classroom B. Classroom A receives an intervention of some kind, so they get that X, and then they have a post-test. And classroom B does not receive the intervention, and they get the same post-test. And then you compare the post-test from the first group to the second group to see if they differ. The key thing here is that the two groups might differ from one another beyond just X. They might differ due to pre-existing differences between the two groups. So for example, the teachers might have a different personality, or the two classrooms might be not necessarily equal in terms of gender or in terms of socioeconomic status. So they might differ in other fundamental ways that could be leading to differences in that post-test observation. Once again, a matched pairs design can cut down on differences between the groups if you cannot randomly assign, but it's still a challenge. And you can't measure initial differences using a pretest in this particular version. This tends to have all the weaknesses of post-test only control group designs as well. If you want to check out that video to remind yourself about the challenges with post-test only control group designs. You might gather here, this is where, once again, you have a pretest and a post-test, and you have a control group, but the two groups have not been randomly assigned. You can test the differences between the first observations for the experimental and control group to see if the groups start off the same, so that gives you a little bit more assurance of equivalency. In this particular case, once again, you have a pretest, some sort of intervention or not, and then a post-test, and that pretest can be compared to see if the groups are equivalent. And even if they're not equivalent, you can measure the trajectory of improvement for O1 to O2 for your experimental group compared to O1 to O2 for your control group in order to take a look at how much people are changing in each of your groups, and if the change is more for the experimental group than the control group. So for example, group 1 may increase and group 2 may decrease even if they start off at different levels. This is slightly better, once again, than any of the other quasi-experimental designs, but it still has some distinct challenges in terms of our ability to determine causation. Even if, for example, the two groups start off as equivalent to one another as measured by your observation 1 compared to observation 1, the two groups might still have some fundamental differences that might cause them to interact with the experiment in different ways. So you still can't be assured that the two groups are truly equivalent. And of course, it has all the weaknesses of pretest, post-test control group designs as well, in terms of the pretest being a potential confound. An interrupted time series design is another type of quasi-experimental design where you take a look at mostly archival data or sampling data over time before and after some sort of intervening event. So for example, if you wanted to know if instituting the death policy in a state lowered the homicide rate, then what you would do is take a look at archival data and take a look at patterns of data before the law was enacted and then after the law was enacted. And then you might see if the homicide rate changed. And once again, having a few years of data helps establish a pattern. It's better than just a single time point before and a single time point after. So you can get a better big picture long-term view. So it might look something like this, where you have 4 observations of the homicide rate, and then the X would be the institution of the law, and then you have 4 years after in order to see what the homicide rate was and whether it changed after the institution of that law to see if there was a difference. A control series design might compare interrupted time series design against a comparison group that did not have the same intervention. So for example, you might compare the homicide rates of a state without the death penalty during those same years as a comparison group. Did all homicide rates decrease even for states without the death penalty, or did it just decrease in the state that instituted the death penalty? And of course, you try to find a matching state. So the comparable state in terms of size, population density, average socioeconomic status, and so on. So this would be what that would look like in terms of instituting a policy and measuring things before in a series of time points and measuring things after, and then comparing it to a control group using those same time points of comparison, but that control group did not have that policy. I'm struck by the representation of data that our governor has been using to compare our infection rates with those of Tennessee. And he's been making the argument that his early policies to close schools and businesses slowed our growth rate compared to that of Tennessee. This would be an example, essentially, of a control series design. Developmental research also has some unique experimental designs that are, once again, a little bit more quasi-experimental. Cross-sectional research explores separate groups of people who are different ages, so a pocket of people who are 5, a pocket who are 10, and a pocket who are 15, and it explores them all in a simultaneous snapshot. It takes a cross-section of all ages simultaneously and takes a look at how they differ from one another. Now, this is fairly easy to implement, but it can expose some generational differences. So for example, 15-year-olds might differ from 5-year-olds not just based on things like their development, but also based off of generational differences in exposure to technology or the type of technology exposed to. So all those things could lead to distinct generational differences, and that could be a potential confound when comparing those 15-year-olds to those 5-year-olds. Think about, I make my intro students do this, and I'll probably make you do it in the discussion. Think about how someone who turned 18 in 2000 might be very different than someone who turned 18 in 2020, just in terms of the different generational differences that exist there. And that can give you an idea of how this can sometimes create problems. So each group has a unique exposure to media, music, and life events that could shape them and make them different on more than just their developmental age. This is known as the cohort effect. The larger the age gap, the more likely there are to have generational differences. So this is just something to think about just a little bit more in terms of one of the challenges with cross-sectional studies for developmental research. And then we have longitudinal studies. So longitudinal studies follow the same cohort over time. I'm going to show you the preview from one of my favorite films, which is a longitudinal documentary studying a group of English people over time, where they've been interviewed every 7 years since they were 7 years old. And now some of them are grandparents, and they're getting older. And it's just very interesting to see that longitudinal documentary, to see those people age and grow over the generations. So I'm going to show you that particular preview in case you want to check it out. It's available for rental, and it's a lovely film. So you might take a look at a group of 5-year-olds and then track them down and study them again at the age of 10, and then study them again at the age of 15. This tends to be a way of studying that eliminates cohort effects or studies a particular cohort in great detail, so there's no problem of generational differences because it's the same generation that's being studied. It's also a repeated design, which is more powerful, also known as within participant design, right? So you can more specifically study generational differences. You can more specifically study the effect of age while eliminating generational differences. There we go. In terms of weaknesses, these sorts of studies are very costly. They take a lot of time and resources. You need to have an experimental team that will endure over decades, and that can sometimes be challenging. Researchers retire, researchers age out, graduate students come and go. The sustainability of this sort of project can be monumental. And then there's also a high degree of dropout, where people who agreed to participate at the start might decide that they no longer want to be a part of it later on, or they might move or lose contact or literally die. That can sometimes happen too.